Welcome to my channel. Today we are going to be looking at another aspect of mathematics for JAMB. We are also WAEC students preparing for the forthcoming WAEC, and you are going to be doing further mathematics. Then this is also for you. So today we are going to be looking at binary operation. Binary operation. So in total, at the end of this class, you will be able to handle the aspect of interpretation and simplification of operations. You will also be able to handle the operation and set operation table. You will be able to handle operation and algebraic law. And lastly, you'll be able to perform the operation properties such as closure, identity, and inverse. These are the four things that this particular topic is meant to cover. So as a student preparing for JAMB or WAEC further mathematics, these are things that is expected of you. So without wasting any much of our time, so let's get started. What is a binary operation? We have different means of combining elements together. Example, we have addition. We have subtraction. We have division. We have multiplication. So these are means of combining numbers together. So, when I want to combine A and B together, I can combine it by saying A plus B. I can combine it by saying A times B. I can combine it by saying A minus B. And I can also say B divided by A. So these are means of combining elements together that we refer to as operation. But there are other forms of operation that we are not that familiar with. So when they say binary operation wants to look at those other types of operation and how to handle them. You and I know how to handle these operations: addition, multiplication, subtraction, and division. If I say 2 plus 3, you know by default that this will give us 5. If I say 2 times 3, you know this will give us 6. If I say 5 minus 2, this will give us 3. So other operations that we are not familiar with include the delta, O dot, O plus, asterisk. You can also have delta facing down, to mention but few. So these are other forms of operation that we are not familiar with. For example, instead of me to write A plus B, I can write A operation B, or I should write A operation B. So instead of A plus B, I'm going to have this. So these are other ways of combining A and B instead of using plus or minus or multiplication or subtraction. So this is basically what we refer to as binary operation. So if that is taken, let's take a look at an example of a problem under binary operation. But before we look at the problem, let's start with the aspect of so we're going to start with the aspect of interpretation and simplification. Okay. Okay. So we look at the very first one that we refer to as interpretation and simplification. Interpretation and simplification. Binary operation. Now, operations are simplified by equating or substituting values when similar or equal operations are given. For example, if I have A operation B, and this is equal to C operation D, How do you interpret this? What this simply means, since you have the same operation between them, that simply means that A equal to C and B equal to D. Do you get that now? So anywhere you find A, you can put C there. And anywhere you find B, you can put D there. Also, if I have A operation B, for example, equal P, and P is equal to 1, then I can conclude by saying that A operation B is equal to 1, since P is equal to 1. So let's take, for instance, that I have A operation B to equal 2 operation 3. That means A is equal to 2 and then B is equal to 3. So anywhere I find A, I will replace with it 2, and anywhere I find B, I will replace with it 3. But let's say I have A operation B equal 2 operation 4, for example. So if you look at the symbol that we have between A and B, that is the operation, it's not the same thing as the operation that we have for what? 2 and 4. So for that reason, A cannot equal to 2 and B cannot equal to 4. So before you can equate them or substitute them, they must be of the same value. That is, they must be equal. The symbol must be the same thing. If the symbol is not the same thing, then you cannot equate or substitute. All right, so if that is taken, then let's take a look at a question on that. So question 1 states that if A operation B equal 2AB plus A, find 2 operation 3. How do you find this? We start by saying A operation B equal 2 operation 3. And we know that A is equal to 2 now, since they have the same operation, and B equal 3. So we have 2 operation 3 to equal, into this now, we have 2 into bracket, A is 2, and then B is 3, plus A is also what? 2. We have that 2 operation 3 equal 2 times 2, 4, multiplied by 3, that's 12, plus 2, we have 14, and that will be our result. So 2 operation 3 equal 14. So it's as simple as that. But let's look at more questions under that. Now, if you look at the second question, we are given that if A operation B equal plus square root of AB, evaluate 2 operation into bracket 12 operation 27. How do you handle this? We're saying tackle the bracket first, just like the board map. We have A operation B equal 12 operation 27. So we are dealing with what is inside the bracket first. So what would this give us? 12 operation 27 is therefore equal to plus square root of 12 multiplied by 27. So when you have 12 multiplied by 27, that will give us 324. So we have 12 operation 27 to equal plus 324. Now, you might be wondering why we have plus here. The reason why we have plus here is that the examiner wants us to pick the positive value only. Because when you take the square root of a number, you're going to have either the positive or negative. Is that taken? But the examiner wants us to just concentrate on the positive. That's why we have the plus there. So 12 operation 27 will therefore give us square root of 324. That will give us 18. So that's tell you that 12 operation 27 is equal to what? 18. So we'll go back to this question now. Instead of having 2 operation into bracket 12 operation 27, then we are going to be having 2 operation 18. So 2 operation 18 is what we are now going to solve for. We therefore have that A operation B that equal to plus square root of AB will now become A operation B equal 2 operation 18. So right now, A equal 2 and B equal 18. Then we have that 2 operation 18 is equal to plus square root of 2 times 18. And 2 operation 18 will give us plus square root of 36. 2 operation 18 will give us 6. For that reason, we can conclude that 2 operation 12 operation 27 equal to 6. And that will be the final answer to the question. So we look at another question still under the operation. I want to believe that you get to understand how to answer questions under interpretation of operation. So let's look at these third questions here. The question says a binary operation is defined over R. What is R? The set of all real numbers such that x operation y equal x squared plus 2y. Find x operation y if x equal 4 and y equal 3. So if you look at this question now, instead of the examiner to ask you that find 4 operation 3, so they are giving you in another manner. So one problem that we always have when we are dealing with math problem is that we always think outside the box when we are not supposed to think outside the box. You do it the way you have been taught, like follow the step-by-step dogmatically. When there is need for you to think outside the box, you are going to know. Are you getting it now? So let's just go by doing exactly what we have been doing before. So we are going to skip one of the steps, because the step where we always compare the two sides of the given function, we have that has been done. We already know that x is 4 and y is 3. So anywhere we find x, we put 4 there. We therefore have 4 operation 3 equal 4 square plus 2 into bracket 3. 4 operation 3 is therefore equal 16 plus 2 times 3, that's 6. And our result is going to be 22. So if that should be the case now, we are done. So in 3 steps, you are done already. So we'll move to the next question. So here comes the next question, and that's question number 4. If x operation y equal 1 operation 5, find x plus 2y operation 3y. So how do we go about that? Very simple. We look into this. So when you look at this now, you're having x plus 2y operation 3y. So let's look for what the value of 2y operation 3y will be. Are you getting it now? So before we can do that, let's just compare here. So we see x is equal 1 and then y equal 5. So if that should be the case, we have that x plus 2y operation 3y, sorry, x plus 2y operation 3y is equal to, our x is 1 plus 2y, that will be 2 into 5, operation 3 into y is what? 5. And this will give us 1 plus 2 times this, that's 10, operation 15. So we have our result that x plus 2y operation 3y equal 1 plus 10, that is 11, operation 15. So, and that's all. So let's move on to the next aspect of the class. Sorry, I think I have this earlier. All right, so let's move on to the next session under this. And what aspect is that? We want to look at operation and set. Operation and set. So when you talk about operation and set, we are talking about the combination of an operation with multiple values called set. When you talk about combination of an operation with multiple value called set, for example, if I have that A operation B, where A and B have several values. The operation can thus be represented by a table called operation table, where vertical and horizontal numbers are taken in order. So for you to get what I'm saying, let's take this. Sorry. So let's say I have operation asterisk here, and I have here A, I have here B, I have here A, I have here B, just like the example given to us. Now, let's say A operation A, let it equal to A operation A, let it equal to P, and A operation B, let it equal to Q, and B operation A, let it equal to PQ R. Okay, so B operation B, that will give us S. So we are going to fill this table now. This is going to be P, this is going to be Q, this is going to be R, and this is going to be S. So if it is more than 2 also, let's take for instance that I have this operation here. So I have this operation here, asterisk, and this is A, B, C. This is also A, B, C. So how do we fill this? So to fill this, you just say A operation what? A operation A, let's say that is P. A operation B, let's say that is Q. A operation C, let's say that is R. And B operation A is S. B operation B is T. B operation C is U. And C operation A is V. C operation B is W. And C operation C is X. So this is how you fill in all these tables. Now, for us to get a better understanding of this, let's take a look at the questions that we can undo under this particular aspect of binary operation. Okay. All right. So if we have this now, we have that given that, sorry, for this popping up. Given that set P is equal to, so we have that set P is equal to 1, 2, and an operation asterisk defined on P by A operation B equal 1 over 2 into A plus B. Deduce the operation table. So how do you deduce the operation table here? Since P is a set of 1 and 2, all you just need to do is to what? Draw your table for the set of P. So the operation that is defined on is asterisk. So here will be 1, here will be 2, here will be 1, here will be 2. All right. So we are told that A operation B. So you have to pay attention here. A operation B is 1 over 2, A plus this. So if I say 1 operation 1, it means A is equivalent to 1. Sorry. It means A is equivalent to 1 and B is also 1. That will give me 1 operation 1 equal 1 over 2 into 1 plus 1, and that will give us 1, because 1 plus 1 is 2. Divided by 2, that's 1, so we put 1 here. Then the next one is 1 operation 2, so we have that 1 operation 2 is equal to 1 over 2 into bracket 1 plus 2. 1 plus 2 will give us 3 divided by 2, that will give us 1 whole number 1 over 2. So we'll fill here with 1 whole number 1 over 2. So the next one is 2 operation 1. So 2 operation 1 is equal to 1 over 2 into 2 plus 1. And that will still give us 3 over 2. And that is a 1 whole number 1 over 2. So we have here to be 1 whole number 1 over 2. So the last but not the least is 2 operation 2. That will be 1 over 2 into 2 plus 2. And that will give us 4 over 2, and that's 2. So we have 2 here. All right. So The operation table that they request from us is just this. So you successfully what? Fill it up now. So that's just it. All right, so let's take a look at another question still on this. Okay, so let me just clean this off. So the question here says, let G equal 0, 1, 2, 3. Define on a binary operation plus on G by A plus B equals C, where C is the least non-negative remainder, got by dividing A plus B by 5 from the table defining the operation. So the first thing is to form the table here. So we have this. It's going to be plus, that's the operation that we are using, and this is 0, 1, 2, and then 3. So this is 0, 1, 2, and then 3. So we have this. Double by my table. So the first thing now is that A operation B, that will be 0 operation 0. So watch now, 0 operation 0 is equal to C. So what is C? Where C is the least non-negative remainder gotten by dividing A plus B. So A plus B means 0 plus 0 divided by 5. So this will give us 0. Because 0 plus 0 is 0 divided by 5, that's 0. What's the remainder? Remainder here is also 0. So we are filling here with 0. So the next one is 0 operation 1. So we have 0 plus 1. So that will be 0 operation 1, that's 0 plus 1 over 5. And that will give us 1 over 5. So 1 divided by 5 will give us 1. Abi? So if we have that, we have 0, remainder 1. So we'll put 1 here. So one is 0 operation 2. 0 operation 2. That will be 0 plus 2 all over 5. So we have that 0 plus 2 over 5, that will give us 2 over 5, and that will just give us 0 remainder 2. Okay, so we fill here with 2, and the next one is going to be 0 operation 3. So 0 operation 3, that will be 0 plus 3 over 5. That will give us 3 over 5. That will be 0 remainder 3. So here is going to be 3. I hope you are getting this now. So if you are getting this, then there's no point for us to waste time and try every other one there. So we can just fill this now. So we have 1 operation 0. That will be that will give us 1. And this will give us 2. This will give us 3. This will give us 4. This will give us 2, 3, 4, 0. So you get this with the same process that we used to fill the first row. So that's how you fill the other row to save our time. So I want to believe that now you understand the aspect of operation table now, which is the second part of the topic that you need to know. All right, so let's move on to the next heading, and that is operation and algebraic laws. Operations and algebraic law. Algebraic law of commutative, operation law of commutative, associative, and lastly distributive. All right, so these are the laws of algebra. So we have the first one, commutative, associative, and distributive. Now, if you look at these laws, there are things that you might have been familiar with, and if you are not familiar with it, it's still fine. But what is commutative? When you say commutativity, what does that mean? So commutativity means a relationship between variables or others, a relationship between others of elements. So that's commutative. And what do you mean? E.g., let's say I have the PQ and the QP. You see that I have rearranged them. It's just like I have 2 plus 3. If it is the same thing as 3 plus 2, then we conclude that the operation of addition is commutative. If I have 2 times 3, and this is the same thing as saying 3 times 2, that means multiplication is also what? Commutative. So for you to know if an operation is commutative, so we say hence, if P operation Q can give us the same result as Q operation P, then we can conclude that what? The operation can conclude that the operation star is commutative. Understand this now? So that's for commutative. So let's look at associative now. Okay. So next one we want to look at is associative. When you say associative, it's a relationship between forms of combination in an operation with elements more than 2. So associative is a relationship between forms of combination in an operation with elements more than 2. For example, if I have P, Q, and then R, so we can have something like PQ and R. We can also have something like P and QR, and at the same time we can also have something like QR and okay, QR and P is already there, so we can have something like PR and Q. You see, within the 3, you see the way we come up with the combination of the form. So if it is a binary operation that is associative, we said that if P operation Q operation R is the same thing as saying P operation Q operation R, then you can say then the operation is commutative. Sorry, is associative. You get that? All right. So let's look at the next one, which is distributive. When we say operation is distributive, so we say it is a relationship between 2 operations when separated and combined. So if I have something like this, if I have that P operation Q into brackets Q operation R, you see this is 2 different operations, and this is just equal to P operation Q operation E operation R. So if this is what we have, then we can say that what the operation, star is distributive over O. All right. So that is how to go about the algebraic laws. Now, if that should be the case, let's take a look at some questions under this also. So the question here says, if PQ equal 2PQ, what property holds for the operation? A, associative, B, commutative, C, distributive, D, complement. So if you look at it, you don't have any property of algebraic law that will refer to as complement. And when you talk about associative, it's between three elements. And when you talk about distributive, it's between two operations. So the ones that can hold is what? Commutative. These standards now. Associative has to do with more than two elements. Distributive has to do with more than one operation. And complement, there's nothing like that. So the answer is going to be commutative. But how can we check? We can check if it is commutative by saying P operation Q equal 2PQ. So if Q operation P can also give us the same result as this, then it means it is commutative. So this is going to be 2QP. Abi? So P operation Q is going to give us 2PQ, and Q operation Q or Q operation P will give us 2QP. Since multiplication is commutative, we say that Q operation P is the same thing as what? As this. And since P operation Q is equal to Q operation P, then we can conclude that the law that holds between them is commutative. Is that taken now? So let's look at the next question, still under this particular algebraic laws. So the next question tells, which of the following binary operations is commutative in the set of integers? So we are looking for the one that is commutative. All right. So if you look at everything here, there's no way we can make a guess, but we can just start by looking at by checking each option. So option A, we have that A operation B is equal to A plus 2AB. So if B operation A gives us the same result, then we can say A is what? A is commutative. Am I making sense? I say, which of the following binary operations is commutative in the set of integers? So let's see. We have that B operation A. So B operation A will become B plus 2AB. So A plus 2AB, B plus 2AB, they are not the same. So that simply means for the first option, A operation B is not equal to B operation A. For that reason, A cannot be the option. So we check B, where we have A operation B to equal A plus B minus AB. So we therefore have that B operation A is going to be B plus A minus BA. So if you rewrite this, B plus A can be rewriting, we can rewrite it as A plus B minus BA can be written as AB. So if this should be the case, we have that A operation B is equal to B operation A. But I don't think there's need to test the remaining ones, because it's not possible for you to have the same more than one options that is correct. So for that reason, B is going to be the right answer. So, and you can take your time to look at every other options there. So for this particular one, this is supposed to be A square plus B. So A square plus B, that will be B operation A is equal to B square plus A, which is not the same thing. So to save our time, that's just that about that. So let's move to the next question, still under the algebraic law. So the next question says, which of the following binary operations is not commutative? Which of the following binary operation is not commutative? I think, okay, it's different from the one we solved now. I thought it's the same thing. So what we'll do again is that we start with option A. Option A is A operation B equal A plus B minus 2AB. So they say which one is not commutative? It means everything there is commutative except one. So let's see the one that is not commutative. So here B operation A is equal to B plus A minus 2BA. So that means A operation B is equal to B operation A. So it means it can be this. Are you getting it now? Okay. So it can be this one that is not commutative. All right. So let's look at the next option. And what's the next option? Next option is option B. Option B is A operation B equal 3A plus 3B minus AB. So this will become B operation A equal 3B plus 3A minus BA. So this is also the same thing as saying 3A plus 3B minus AB. Are you getting this now? So for that reason, we have that A operation B is equal to B operation A. So this cannot also be the one that is not correct. So the next one is option C, where we have that A operation B is 2 over A plus 2 over B. So B operation A is going to be, so B operation A is going to be 2 over B plus 2 over A, and you can rewrite it, that is B operation A, can write this as 2 over A plus 2 over B, and we can conclude that A operation B is equal to B operation A. So it can be this one also that is not correct. Okay guys, I know you're about to conclude that then the right answer is going to be D. So don't make that mistake, because at times you might not find option in a particular question. So let's try the third one and see before we make our conclusion. And the last one, which is option D, says A operation B equal A minus B plus 2AB. And B operation A will become, this will be B minus A plus 2BA. So is there a way we can rearrange this? Yes, we can also rearrange it also to make A come first. So we have B operation A to equal to negative A plus B, then plus 2AB. So if you look at it, this is negative A and this one is positive. This is negative B, this is positive B. So A operation B is not equal to B operation A. So the correct answer to this is going to be D. All right. So if that should be the case now, I believe everybody understand the aspects of algebraic law with binary operations. Okay. So let's take it a bit more. Let's look at more questions on this, because this can be tricky at times. So we are told that if an operations asterisk and O are defined as P operation Q equal x plus 3 and P operation R equal 4x and A operation B equal 2A plus B, find P asterisk into bracket P operation R. So how do we go about this? So for distributive, we know, you first of all recall that for distributive, we have that P operation Q operation O is equal to P operation Q, then operation P operation R. Is that taken now? So we therefore have that using A operation B equal 2A plus B, we have that P operation Q, then operation P operation R to equal to, so anywhere we see A, we are going to represent it with P operation Q, because that is what A is equivalent to. Am I making sense now? So we have 2 into bracket P operation Q plus Our B is going to be P operation R. So P operation R. Then you now ask yourself, what is P operation Q? That is X plus 3. Then plus, what's P operation R? That's 4x. You therefore have 2 times x, that's 2x, plus 6, then plus 4x. And this will then give us that. P operation Q, then operation P operation R equal 6x plus 6. So this should be the final results for this particular question. I hope everybody gets this. So let's go to the very last part of today's class before we'll call it a day. So the very last part of today's class is talking about operation properties. Operation properties. When you talk about operation properties, the very first one that we're going to be discussing is what we refer to as closure. When you say closure, an operation is closed if the resulting combination is the same in nature with the original element. That's when they say an operation is closed. Like if I have an odd number, if I combine odd number and odd number, then if my result is odd number, then I can say that what? It is closed. If I find rational numbers and then it gives me rational numbers, if I combine rational number and rational number and my result is still what? Rational, then I can conclude that what? Such operation is closed. Let's give an example. If I had 4 and 3 together, 4 and 3, they are whole numbers, right? So odd numbers, if I add 2 odd numbers together, I will get an odd number. So for that reason, odd number is closed. That is, addition is what? Is closed. Addition of odd number is closed, because when you add 2 odd numbers together, you will have what? Odd number. Okay, let's see. If I add 2 even numbers together, will I get even number? Of course, I will get an even number when I add even number and even number together. So I will say this operation is closed. But if I had odd number and odd number together, let's say 3 and 3, these 2 odd numbers, if I add them together, my result is 8. It's not closed. So the addition of 2 odd number is not closed. Okay, let's see if I divide 2 odd number. Let's say 6 divided by 2. That will give us 6 divided by 2. That will give us 3. So we divide whole number by whole number and it gives us whole number. So can we say it is closed? Let's say 6 divided by 4. This is whole number. This is whole number. This will give us the 2 can go here 3. 2 can go here 2. So that's 3 over 2. So if I have 3 over 2, then this is not closed, because I have what? The division of whole number, and it gives me what? It gives me a rational number. It's supposed to give me an whole number, so it's not going to work. It means it's not working, even if it works for 1, but it doesn't work for the second one. So that does not mean that it works. It must work for. If I pick another odd number now, let's pick another odd number. Let's say 7 plus 3. That will give us 10. It's an even number. So this is close. Do you understand that now? So if it works for 1 and it doesn't work for the other, it is not close. It has to work for both. Okay? So that's that about closure. So the next one is what we refer to as identity. When we say identity, what is an identity? An identity is a number added to or multiplied by another number such that the number does not change. So what you say, this is an identity. If I add that thing to another number, I get it now, it must still give me that same number. For example, if I say 2 plus 0, I'll still have 2. No any other number that I can add to 2 to still get 2. Therefore, I will say is 0 is an identity. Now, and if I say, let's say 3 times 1, that will still give me 3. There's no any other number that I can use to multiply 3 that will give me 3 other than this one. I get this now. So for that reason, I'll say 1 is an identity. Am I making sense now? So 0 is an identity of addition. They ask you what's the identity of addition? Is what? 0. An identity of multiplication is what? Is 1. So identity of multiplication is 1. I believe you understand that now. Now, how do we use this in an operation? In an operation, identity is represented by letter E. If you have an operation, identity is represented with letter E, and also combined with another element to produce the same element. So, let's for instance that I combined A operation E. So if I say A operation E, remember E is an identity. So my result must be what? A. Remember, when I combine identity 0 with 2, my result is still 2. So if I combine B and E, my result will be what? B. If I combine C and E, my result will still be what? C. Are you getting it now? That is an identity. Do you understand that now? So, and when you want to carry out operations involving identity, then you have to substitute for the second one. That is, let's take for instance that I have like this. Let's say I have A operation B equal AB, for example, and I'm looking for the identity of this of A or for this, or they ask me to find the identity element. So I'll substitute B. Always substitute the second element with E. So that will give me what? That will give me AE. Abi? So, and you know that this now, if I combine A operation E, my result must be what? A. So this will be AE. Then divide both side by A. So you have that the identity of this is 1. All right. So if that should be the case now, let's solve some well-constructed question under identity. All right. Okay. We have that an operation defined. An operation is defined on a set of real numbers. Okay. No, this one is inverse question. Okay. All right. Yeah. This is a question here. So an operation O is defined over set of real numbers by, okay, sorry, it's supposed to be x operation y equal x plus y plus x square y, not x2. So this is supposed to be square. Sorry, permit me that. And then, so what's the next thing? Operation O is defined over set of real numbers by x operation y equal x plus y plus x square y. Find the identity element A 0, B 1, C negative 1, D undefined. So how do we find the identity element? We substitute y with E. Are you getting it now? So you therefore have what? X operation E equal x plus E plus x square E. Are you getting this now? So you know that when you combine x operation E, since E is an identity, your result is going to be what? Your result is going to be x. So you have that x equal x plus E plus x square E. Are you getting this now? So this is what we are going to have. I want to make E the subject of the formula. So for us to do that, take this one to the other side. Then you have x minus x into what? E, then 1 plus x squared. So if this should be the case, I will be having x minus x will give us 0. So 0 equal E into 1 plus x squared. Then I have that E is equal to 0 divided by 1 plus x squared. So E is equal to 0. So the correct answer to this is going to be A. So let's take a look at another question other than this. I believe you understand this now. So that's how to find the identity of an element, so of an operation rather. So the next question says that if Z is the set of integers and as operation asterisk is an operation defined by A operation B equal A plus B plus 1 on Z, find the identity element. So simple, just substitute B with E. Then you have A operation E equal A plus E. Sorry, I think I did not write that. So A plus E plus 1. Are you getting this now? So this will still give us what? A. So we have A equal A plus E plus 1. So take this on to the other side of the equation. You have 0 equal E plus 1. So the value of E is negative 1. So the identity element that they ask us to look for here is negative 1. So that should be the case now. I believe you all understand the concept of identity now. So let's move on to the concept of inverse. So we want to move on to the aspect of inverse. So when you talk about inverse, that is another interesting aspect of the properties of an operation. Now, what's an inverse? When we ask you, an inverse is a number added to or multiplied by another number to give 0 and 1 respectively. So when I say a number is an inverse, when you add that number to another number, if that number is truly the inverse of the number that you add it to, your result is going to be 0. And if you use a number to multiply another number, if that number is truly the inverse, your result is going to be 1. Do you understand that now? So let's take, for instance, if I have 2, I add minus 2 to 2, my result is 0. Or if I have 2 and I multiply it by 1 over 2, my result is going to be 1. So for that reason, I'm going to call minus 2 and then 1 over 2 to be what? An inverse element. So minus 2 is going to be the inverse for addition, and 1 over 2 is going to be the inverse for multiplication. You understand that now? All right. So that's that about inverse. So what's the next thing for us to do now? Let's take some questions now. I want you to note something before we take question. You get to see that when you combine inverse of an element, so you can see when I combine the inverse of 2, what do I have? I have identity. So if I combine A and A inverse, my result is going to be what? Identity of it. You understand that now? So that simply means that whenever you are to look for inverse of an element, then you must know the what? The identity before you can find the inverse. All right. So I think that should be the next question. No, solve this before. We have this now. When we say find the inverse of a real number y under the operation A operation B equal 4AB. So how do I go about this? So the first thing is that you should find the identity first. So to find the identity, we have that A operation E is equal to 4AE. So since this one is going to give us A, we have that A equal 4AE. So E is equal to A divided by 4A. So that this and this can cancel. And we have that E equal 1 over 4. So this is the identity element 1 over 4. Now we can find the inverse of A. But we have to find the inverse of A in terms of Y. So how do we do that? All you just need to do is to change A to become Y, operation Y inverse. And this will equal to 4A, so that will be 4Y multiplied by Y raised to power minus 1. Are you getting this now? So you know that when you combine a number and its inverse, it's going to give you the identity. And the identity of this is 1 over 4. So you have 1 over 4 to equal to 4Y multiplied by 4 raised to power minus 1. So you are looking for 4 raised to power minus 1. So you are looking for y raised to power minus 1. So divide both sides by 4y. You therefore have 1 all over 16y. So the inverse of this particular function is going to be what? 1 over 16y. And that will be the right answer to the question. Okay, so what's the next one? So the next question here states that an operation star is defined on the set of real numbers by x operation y equal x plus y minus 2xy. If the identity element is 0, find the inverse of element p under the operation. So that's to tell you that we are going to replace x with p, and we replace y with p inverse, and that will give us p plus p inverse minus 2p p inverse. Are you getting this now? You know, this will give us the identity, which is what? 0, and that will give us p inverse. Let's take this p to the other side. So let me just rewrite this: p plus p inverse minus 2p p inverse. So take this p to the other side. You have p to equal to p inverse minus 2p p inverse. So factorize out p inverse. You have that p, then p inverse into 1 minus 2p. Are you getting this now? So p inverse that we are looking for is therefore equal p divided by 1 minus 2p. So that will be the inverse of the function that we are looking for. Okay. Oh, that's a mistake here. So this is supposed to be negative p. Yeah, this is supposed to be negative p. So if this is negative p now, I can have it like this, or I can have it like this, or I should have it as p all over 2p minus 1. So either of the two will be the correct answer. So do you understand that now? So let's take the last question under the last part of this particular topic, and we can call it a day here. All right, so this is the last question here. And what was the last question state? The last question says a binary operation star with identity element 0 is defined on the set of real number. Are you getting this now? By m operation n equal, so we have that m operation n equal m plus n plus 2mn. Where m and n belongs to the set of real number. For what value of m does the operation has no inverse? So what does it mean for an operation to have no inverse? An operation is said to have no inverse when the inverse is equal to 0. Are you getting this now? When the inverse is equal to 0, then the operation said to have no inverse. You understand that? All right, so let's see how that goes. Okay, so how do we go about that? We start by, since we are told that we should look for the inverse, so that will be m operation m raised to power minus 1, and that will equal to m plus m to power minus 1 plus 2m m to power minus 1. So if that should be the case, this is going to give us what? The identity, and we are told that that is 0. So we have 0 equal m plus m inverse plus 2m m inverse. All right, so take this on to the other side. We have minus m equal m inverse into 1 plus 2m. So we have that m inverse itself is equal to negative m all over 1 plus 2m. So this is the value for m inverse. So if this operation is not going to have an inverse, like the question states, then m inverse must give you 0. Are you getting it now? So that means we are going to say negative m over 1 plus 2m is equal to 0. So when you cross multiply, you have that negative m is going to be 0 multiplied by 1 plus 2m, and that's to still give us 0. So the value of m that will make this function or this equation not to have an inverse is going to be 0. So I believe we all understand this now. So that should be the case. Don't forget to subscribe to this channel, share the video within your friends, practice more questions under this aspect of mathematics. Until then, keep practicing, keep practicing. You are going to blast JAMB, promise you. And let's look for the next video on this channel. Thank you, guys.